Okay, so we've already gone through the quality assurance check with the swerve method. We're now going to go through the quality assurance check with the transverse line method. On this screen with your file information, everything is actually identical to as if you were doing a swerve, where you have quality assurance selected, you're in distance collect mode. You do want to put your starting station number, and in this case we're actually at 70 plus 10, and I'm getting that information in this case from my live output from my TOPCon controller. And if you were with uncorrected GPS, you'd probably want to try to do your transverse lines at stake locations so you could input your correct station number that way. In this case, decreasing distance does not apply because we're going to be moving transversely along the pavement. We're still in the westbound lane, and our lateral offset is going to be the full lane width. So again, this one we're going to put 45 just to indicate that we're doing a transverse line test, and we're still left of the reference line because we're testing to the left looking up station in the westbound lane. So everything else can remain the same. You might want to put line test in the comments just to indicate that this is a quality assurance test, and include with field measurements for display and export. We like to keep that selected so you also get it in your main exported data. So we're actually now ready to put our cart into place. The reason we're shooting the video here is because when you're doing a transverse line test, oftentimes you have to have the cart in the adjacent lane to be able to get a full 12-foot line. You may have to shorten your line depending on the traffic control situation, or do a longitudinal direction line, but the concept will remain the same. So we're now ready to move to the starting position with the right sensor located on top of the line. We're now into the repeat line, which is in the same quality assurance module that the swerve was collected, but now we've highlighted repeat line, and we're going to give it a measured distance of 12 feet, which corresponds to the full lane width. You can see, if Jeff zooms out here, that the rightmost sensor is located along the line. So we're going to press the right sensor when we begin our data collection. So I'm going to move the right sensor so that it's at the center line joint. I'm going to press right to indicate that that's the sensor we're evaluating right now, and I'm going to start moving forward with the cart along this line. And we're now still moving along the lane width, and I like to move so that I'm centered with the sensor here. I see I'm moving a little bit to the left of the line, so I'm slightly correcting as I go. And as long as you're generally along that transverse line, this should be a good repeat test for quality assurance. It's now indicating that sensor number 305 is complete, and we're ready to move to the center sensor. Okay, we've now completed our right sensor, so we're moving on to the center sensor. And one way you can make sure you're on the correct spot is to just move until your green dot is located right on your line here. And now, once you're ready to collect, you press the center sensor, and it's ready to collect data. So as I move along, I'm just trying to center my sensor as best as possible along this chalk line, and once I've completed that test, it says sensor number 303 complete. We're now ready to move to the leftmost sensor. Again, with the leftmost sensor, similar to the other two, you're going to want to go until you get to the start where the green dot is lined up directly at the beginning location. You'll press left sensor, and now collect data moving forward. And here you want to do the best you can to keep the center of the sensor directly above that chalk line. And as soon as you've conducted the 12-foot stretch, you can actually see the results. Okay, once we've conducted all 3 passes on the repeat line, you get results listed here below. Typically, when you run this test, you will be just outputting the dielectric value because you won't have the calibrated sensors. But we already have our mix calibration entered in, and we're outputting our percent GMM. So this allows us to compare what the difference or bias between sensors means in terms of difference in predicted percent compaction. And what we have for results here is left sensor 92.51, center sensor 92.45, and right sensor 92.36. This means all 3 of our sensors are measuring within 0.25% air voids of each other, which is not to be expected typically, but a very, very good result in terms of feeling comfortable that your sensors are unbiased in this case.